Alright, so now that we've built a rocket, it's time to test it. First of all, your rocket should fit semi-snug onto this PVC pipe, but not hug it too tight. And the first step we want to do when we go to test our rocket, is to connect these two PVC pipes with this 90-degree joint. Check out what's next. You can do this in a different order. I'm actually going to take this apart and slide it inside the 2-liter bottle. This is probably one of the only instances in our project where the more you use, it won't hurt you. Go ahead and tape the PVC pipe to the 2-liter bottle using a tape receiver. It's important for no air to leak out here, so be generous with the amount of tape. It's not the prettiest tape job. But it'll get it done. Be generous with the amount of tape you use and give it a nice hug at the end to make sure no air squeaks through there. Go ahead and reattach that 90-degree elbow and slide your rocket on. Are you starting to see how this is coming together? Let's go outside and take it for a lunch. Once you've found a good area to test your rocket, find a couple books. Sorry, that's my dog barking at some birds. Anyways, find a couple books that let your PVC pipe rest flat against the ground and make sure your rocket can shoot straight up in the air. Here's the technique to launch your rocket. It's called a stomp rocket for a reason. We're gonna stomp this PVC pipe and it's gonna launch all the air and create some air pressure through the tubes, launch the rocket up. When you do go to stomp it, the right technique is to do it nice and fast and like that. We're not gonna step on it parallel to the bottle because that's gonna break it. Whoops. We're gonna wanna do it nice and fast and just perpendicular to the rocket. 3, 2, 1. Bella, say hi. Bella, say hi. So it's a blast getting out there and launching the rockets, but here's the best part. Is you can blow it right back up and do it over again. Believe it or not, we actually developed a way where you can find out how high your rocket flew. Using trigonometry and angles, we developed this little file that you can go to the rocket page and download, print out. Sort of attach it to a ruler or something straight like this, and what you do is you aim it at the rocket as it gets higher and higher, and at its highest point, see where the string lies. We'll tell you what to do from here. First of all, this is sort of how we'd like you to cut out and attach this document to a ruler so you can get a proper measurement. Find a piece of string or yarn and poke one end through the shaded hole on the piece of paper and tape it to the back side. On the other end, attach some sort of weight to it. Watch the angle that your string reaches very closely because that number becomes really important in our calculations to see how high the rocket goes. That angle you come up with is actually your number that you can see inside the yellow portion of the triangle. The section that says blank feet is how far you are from the rocket when you go to launch it, so be sure to keep track of that. Go to Google or find a calculator, and the calculation you want to do is enter how many feet you're standing away from your rocket times the tangent of the angle that you got. It's not the most precise way, but it gives you a good idea of how high your rocket flew. Here's a quick sample calculation. Say you were standing 20 feet away from the rocket, and you measured that it flew an angle of 48 degrees above from where you're standing. This is the calculation. Don't forget to factor in how tall you are too. That makes a difference. Here's a couple quick clips of me doing the process by myself, but it's pretty helpful to have a buddy. So thanks a ton for tuning in, friends. Remember, if any questions pop up about the rocket build, or how to test it, or even the trigonometry behind this little device we developed, please take advantage of our Zoom calls. We'd love to get to know you better, and we can't wait to see what you come up with this month. Have a great rest of your week, everybody. Thank you.